Hello once again and welcome to this video. In this video we're going to be looking at the exercises that will enable you or allow you to practice drawing the structural formulae of various compounds. So in this basic video what we're going to limit ourselves to is the drawing of structural formulae of hydrocarbons. In this particular example, these particular examples will be looking at your alkanes. So the important thing that you need to remember when you're going to draw the structural formulae of these substances is you need to first of all identify the main group or the main chain, and also to remember how many carbons there are in that main chain. And then the others become the substitute groups, and you need to know where they are substituted in the compound. So things to remember: one, the main chain. Identify the main chain, and when you've identified the main chain, you need to know how many carbons are in the main chain. And then thirdly, you must be able to number the carbons accordingly. So you must number the carbons correctly so that the substitute groups would occupy the lowest number possible after the functional group. In the particular functional group. And then you must also remember that when you name these, you name them according to the alphabetical order. If you've got various groups that are attached to the thing, there is no priority or preference of halogens over the alkyl groups. It's whichever occupies the smallest number possible, and that's how the numbering is going to take place. All right, so I'll look at the first example. In the first example, what you have is you have a simple example that says draw the structural formulae of the following, which is 2,3,5 trimethyl octane. So the first thing that you need to do is to identify your main chain. So our main chain in this particular example is the octane. So octane has got how many carbons? You know that there are 8 carbon atoms in the chain. So that's what you would need to represent. So the idea would be to represent that in as straight a chain as possible, and then from there start numbering your carbons, and then you would be able to identify the substitute groups. What are the substitute groups that you have? You've got the methyl group as a substitute. So that's a substitute, right? So it's an alkyl group that is attached to the main chain. And how many of these methyl groups do you have? This gives you the number of the groups that are attached. There are 3 of them. 3 of identical substitute groups which are attached to the main chain. So hence the prefix tri. And where are they? This gives you the location of those identical groups that are substitute groups that are there. So this is the location of the substitute groups in the that are attached to the main chain. So they're found at position 2, position 3, position 5, and they are methyl groups that are on that long chain. So I'll give the first example, and that first example is as follows. Just create space. So you've got your 2,3,5 trimethyl octane. So the first thing that I'm going to do is to make sure that I have my octane group, which has got 8 carbons. So solution question 1. So it's got 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. So these are my 8 carbons: 1, 2, 3, 4, 5, 6, 7, 8. And then I've got my substitute groups, which are methyl groups, and they are found on carbons 2, 3, 4, 2, 3, and 5. So I'm just simply going to look at this and come from left to right, and then I'm going to number them. This is carbon number 1, this is carbon number 2, 3, 4, 5, and that's carbon 6, 7, and 8. So on carbon number 2, I've got a methyl group. Take note, it's not ethyl, it's methyl. So on carbon number 2, I've got a methyl group. And the methyl group is made up of a carbon, and a single carbon, and there are hydrogens on it. And that is attached to the main chain. And then on carbon number 3, I have another methyl group. I can put it here on top, it doesn't really matter, but for space and clarity, I'm just going to put it here on top. So it's another methyl group which is identical to that. So it's a methyl group, it's got a carbon and it's got 3 hydrogens. And remember, at all times count tetravalency around the carbon. And then I've taken care of 2, 3, and then position 5. In position 5, I've got another methyl group. So now with that, I now have my 3 methyl substitute groups found at position 2, 3, and 5. So I've got 2, 3, 5 trimethyl. They're all the same, so hence trimethyl groups. And thereafter, I need to make sure that all my carbons have got enough hydrogens around them. And so I'm going to now place all my hydrogens as I should. So here there's 1, 2, 3, and so I'm short of a hydrogen here. Here I've got 1, 2, 3, 4 bonds, short of a hydrogen. Here I'm short of 2. And then here I've got 1, 2, 3, my 4th bond. And then another 2 here. And then another one. Another one. Another one. And another one. That's it. You find that everybody is accounted for, and there is the structure of the compound that you're asked to find. Right? So in the next example, I'm going to give you a chance for you to try and write the formula of trimethyl 4-propyl heptane. Right, in the example where you have to represent the formula of 2,3,4 trimethyl 4-propyl heptane. Again, you've got to identify your parent chain, which is the propyl heptane. Right, so in this case, it is not just a plain heptane structure. There's a substitute on it, which is the propyl group on carbon number 4. You also have the 3 methyl groups that are attached on positions 2, 3, and 4. So that's what you need to take into account. So in this case, the first thing that you must do is to represent the long or parent chain of the propyl heptane, 4-propyl heptane. And this is what you would then go on to do. So you have your heptane, which has got 7 carbons. 2, 3, 4, 5, 6, 7. So there are 7 carbons, and then on carbon number 4 there is the propyl substitute group that is attached. So you count and you identify your carbons. So this is carbon number 1, number 2, number 3, carbon number 4, 5, carbon 6, and carbon 7. And so on carbon number 4 you've got the propyl group that is attached. So carbon number 4 you've got the propyl group. The propyl group would have 3 carbons. So you've got that 1, 2, 3. So that is that alkyl radical that is attached to that. And because you are representing the structural formula, it is important that you give the structural formula of the radical as well. So it's on carbon number 4, so that part is taken care of. And then on carbon number 2 and carbon number 3 and carbon number 4 respectively, you have the methyl groups that are present. So you've got the methyl group on carbon number 2, and the methyl group has got a single carbon. And then on carbon number 3 you've got another methyl group. And then on carbon number 4 you also have another methyl group. So you have taken care of all the substitute groups that are present, and then now you just need to make sure that the hydrogens that form part of the molecule are also present. Count 4 bonds around each carbon. So now when that is said and done, you check that every part of the molecule, part of the name is taken care of, and that is how you would represent your 2,3,4 trimethyl 4-propyl heptane. The next molecule that needs to be represented is 5, then 1,1-dimethyl propyl octane. 5,1,1-dimethyl propyl octane. So have a look at it, try and represent it, and then we will give you the solution shortly. Right, the solution to this question is as follows. So you've got your compound, which is given as 5,1,1-dimethyl propyl octane. So what you need to first of all do is to identify the parent chain, so which is the long chain that is present. So when you look at this, the name tells you it's octane, and that octane has got how many carbons? Got 8 carbons. So there must be a long chain which has got 8 carbons, but on that long chain there is a substitute group which is the dimethyl propyl. Right, so there's the 1,1-dimethyl propyl. So it's dimethyl and a propyl group, which is on carbon number 1. So it's 1,1-dimethyl octane, and there is also so you've got your dimethyl propyl group, which is attached on carbon number 5. So this is the location of this substitute group, which is your dimethyl propyl group, which is attached on carbon number 5. The substitute group itself has got a substitute. What does it have? It's got a dimethyl group on carbon number 1 of that particular substitute group. So when you represent this, it's important that you take note of the following: that your longest chain has got 8 carbons. So 8 carbons, which we shall represent. So 8 carbons: 1, 2, 3, 4, 5, 6, 7, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. So now on carbon number 5, that's what you need to understand. Carbon number 5. So you count carbon number 5. So let's number carbons: 1, 2, 3, 4, 5. On carbon number 5, and that's 6, 7, and 8. On carbon number 5, we have got a substitute group, which is that which has got 3 carbons. The propyl group has got 3 carbons. 1, 2, 3. And then on the carbon number 1 of the substitute group, there is going to be your dimethyl group. So if this is carbon number 1, number 2, and number 3. So you're going to have your dimethyl group. So you're going to have a methyl group here and another methyl group here. So it's 1, 1 dimethyl group. And it's stuck on the propyl group: 1, 2, 3. And then on carbon number 1, you've got 2 methyl groups, hence the name dimethyl groups. And then from there, you've got everything that needs to be included. So where is it found? I've put it on carbon number 4. It should be on carbon number 5. So I'll just simply allow me to just simply change this to 4, or I should just change it. Let me cut this and locate it where it should be. This needs to be moved. Delete. It should be on carbon number 5. There are the hydrogens. There's your propyl group, it's got 3 carbons. And then this is your methyl group, it's got a carbon. And then there's the other one's got a single carbon as well. And it's attached to carbon number 1, which is attached to carbon number 5 of the main chain. So you would place that there. And you've counted all your hydrogens. Then you've got the whole structure of the compound as you need. Right, then the last part, or the last exercise, you are supposed to give the structure of 4-chloromethyl 5-methyl hexane. 4-chloromethyl 5-methyl hexane. So what you are expected to do again. Have a look and then decide what your main chain is. So the main chain that you're looking for is a hexane, so it's got 6 carbons, and then on carbon number 5 you've got the methyl group attached to it, so that's a substitute group which is attached to carbon number 5 of the main chain. And then you've got on carbon number 4 you've got the chloromethyl group attached to it. So basically what it looks like is this: there are 6 carbons, 1 2 3 4 5 6. Number your carbons: number 1, number 2, number 3, number 4, 5, 6. On carbon number 5 you've got the methyl group. Carbon number 5 you've got the methyl group. And then on carbon number 4 you've got the methyl group. Let's see if we count 5-methyl hexane. So you've got a methyl group here, and then on carbon number 4 let me change this to octane, otherwise it will look different. Octane, if it is carbon number 5, 6, 7, 8, and then we can count 1 2 3, 1 2 6 7, and then 8, because if we count it as octane you will be able to write something that makes more sense. And then carbon number 3 and number 5 here. So this will be your chloromethyl, 4-chloromethyl. So you'll have the chloro group here on the chloromethyl, that's the carbon number 4, and then from there you would be able to write it this way. Add all the hydrogens. The reason we had to change that from the hexane, it would not be possible to have the substance being named as 4-chloromethyl, 5-methyl octane. The numbers would have to change, because if this was the last carbon in the chain, this would not be carbon number 5, but this would be carbon number 2. So it would not be possible to call that 5-methyl hexane, and this would all be carbon number 3. So it would need to shift that way. But once it shifts that way, as carbon number 4, it would mean that the other one stops being your 4-5 cannot be practical to have that as your your methyl hexane, the parent chain being the hexane group. It's too short, so we had to make it longer. So hence we resorted to having it as an octane. So that is the solution. And so if you liked it, if you've got questions, you've got comments, please send your comments through, and then we will see you in the next video. Please like and share, and look out for the next video. Thank you.